right, we're about to roll up now. Section 8.4. Yeah. Okay, so now what we're going to do is we're going to now switch little roles here, and we're going to start to add and subtract radicals. All right? And so we have to have two prerequisites if we're going to add or if we're going to subtract radicals. All right, so the two prerequisites that must be true if we're going to add or combined, basically we're just combining like terms, is the index. So the number that's right here where this little bloop is, that number must be the same. So right now we know that there's a ghostly 2 and there's a ghostly 2. So the index must be the same. And what's underneath the radical, or what we call the radicand. Okay, so the radicand and the index must be exactly the same if we're going to add or subtract two radicals. All right, so looking at example A right here, as you can see, they both have a 2 and they both have a 5, so we can add these two together, meaning think of the radical 5 as like some kind of variable like x. So if I were to say, hey, what's 3x plus 7x? Oh, you just say, oh, well, there's 3x's here and there's 7x's there, so that's 10x, right? So in the same way, we're going to think of the radical 5 as just some kind of variable. So it's like radical 5. So when we say 3 radical 5 plus 7 radical 5, that's just going to be 10 radical 5. And that's how that works. And, from what we know about radicals, we can't break down, we can't simplify radical 5. We leave it just like that. All right? Let's move on over here. So right here we have a 2 radical 11 minus radical 11 plus 3 radical 44. Okay, so the first thing that we should notice is that, oh, look, these are the same. They have the same index and they have the same radicand. So since that those are the same, we can go ahead and combine those together. These two can be combined as, look at here, 2 radical 11 minus 1 radical 11. There's like a little ghostly 1 right there. The little ghostly ghost. So 2 minus 1 is going to be a 1 radical 11. But we don't have to put the 1 right there. But 2 minus 1 is we have one of these left. And then we have our plus 3 radical 44. Now before we stop and we're like, oh yes, we're done. We need to check, can we simplify radical 44? And since we have awesome radical skills now, we can go ahead and simplify radical 44 right there, right? So let's see what we can do. What perfect square number, right? What perfect square number goes into radical 44? Let me think about this right here. 4, right? So I can rewrite this as 3 times radical 4 times radical 11, because radical 4 times radical 11 is radical 44. You see what I'm saying right here? So we can break this down as a product. And then this becomes 3 times 2 times radical 11, because square root of 4 is 2. And then this right now becomes 6 radical 11. Oh, dang. And now look at this right here. We have radical 11 and 6 radical 11. Dang. So we can combine those together. Okay. So let's just, this guy then gets brought down. So we have radical 11 plus this right here. So 1 radical 11 plus 6 radical 11. So that's a 1 plus 6. So our final answer is going to be 7 radical 11. And that would be our final answer. Let's go on to part C here. Oh boy, look, we have 5 radical 12y plus 6 radical 75y. Well, these don't have the same radicand. They have the same index, right? There's a 2 right here, and there's a 2 right here. So what we have to do is we have to get creative. We got to manipulate the problems so they can have the same radical here. So let's first deal with this guy. Let's rewrite radical 12. How do we simplify radical 12? Well, we can rewrite that first. Let's do this. I can rewrite that as radical 12 times radical y, right? So this is what we did last section. Okay, now let's break down radical 12. 5 radical 4 times radical 3, and that's still a radical y. Okay, so square root of 12 just became square root of 4 times square root of 3. 4 times 3 is 12. And the square root of y just still stays underneath its own radical. And then check this out. Square root of 4 is 2, so 5 times 2 radical 3 radical y. And now this whole thing can all be simplified down to be 5 times 2 is 10. And then since both of these have the same radical, I could just say that's radical 3y. Okay, so basically all we do is we took this guy and we wrote it down here. Okay, now let's do the same thing for over here. What we're hoping for is that when we simplify this, it's gonna have a radical 3y, and we'll see here. First of all, let's rewrite this radical 75y as 6 times radical 75 times radical y. Cool beans. All right, I got you, dog. Now, let's see. Radical 75. What perfect square number goes into 75? What's the biggest one? 25, right? So 6 times radical 25 times radical 3 times radical y. Right? 3y. I. So radical 25 is just 5. So 6 times 5 times radical 3 times radical y. So this can all be simplified down to 30 radical 3y. Nice. And so let's just drop down our plus sign. So 10 radical 3y plus 30 radical 3y. Just do 10 plus 30. So we have 40 radical 3y. Sweet. And there's that dude. All right, let's go on down over here to this last guy. Okay, 9 radical 5 minus 4 radical 10. Okay, so they have the same index, but not the same radicand. Interesting. Can we simplify radical 5? Well, we can't, right? We can't simplify a radical 5 because there's no square number that goes into 5. Let's see. Is there any perfect square number that goes into radical 10? Well, no. So there's nothing that goes into 5, nothing that goes into 10. Well, then how do we do this? The answer is it's not simplified. Or not, but like it can't be simplified. Oops. And so basically, you could just either leave the answer that way or just say, oh, hey, like it can't be simplified. And probably like on your homework on the quiz is going to say like one of the options you can't simplify it, or maybe you have to type that in. But and so sometimes you do have those kind of cases where it's just not simplified right there.